In this video, we'll be solving an equation that contains two radicals. The equation we'll be solving is the square root of 3x plus 1 subtract the square root of x plus 4 is equal to 1. Now I'll show the step that we'll be using here on the left, and then I'll actually do that step on the right. So our first step is to isolate the radical on one side of the equation. If there's more than one radical, isolate one of them. So here we see that we have two radicals. So I'm going to isolate the square root of 3x plus 1. So I'll keep that on the left, and I'll move this radical to the right by adding square root of x plus 4 to both sides of the equation. So I have then square root of 3x plus 1 on the left side, and then equals, and when I add that to the right, it'll become a positive. So 1 plus square root of x plus 4. My next step is to raise both sides of the equation to a power that's the same as the index of the radical. This will eliminate the radical. Now in this case, it'll eliminate the one that we isolated, but we'll still have this one involved. Let's look at that. The square root has an index of 2. Square root is so common that you don't write the little index, but we'll have to raise both sides to the second power in order to eliminate this radical. So the squaring of a square root on the left side here will just give me 3x plus 1. Now be very, very careful here. When you square a binomial, it's important that you realize that that means that you're multiplying the binomial by itself. So I'm going to actually write that. Because we have to use FOIL on this right side in order to square this expression. Too often students think that they can take a shortcut and square each term and they're done, and that doesn't work. And you'll see that in a minute. All right, so let me copy the left side, 3x plus 1 equals. Now if we use FOIL, we'll multiply 1 times 1 is 1. And then 1 times this radical is plus square root of x plus 4. Now we're done with the 1, so let's take this radical through. The square root of x plus 4 times 1 is plus square root of x plus 4. And then square root of x plus 4 times square root of x plus 4. We'll just have the radicand left because it's the same as squaring it when you take it times itself. So back here then we just have an x plus 4. Now we can combine some terms. We'll add these two radicals together. We have 3x plus 1 equals, I can add the constants together here. 1 plus 4 is 5. So I have 5. And then I still have this x here, and then I have 2 of those radicals, so 2 square roots of x plus 4. I can simplify a little further. Because if the equation still contains a radical, we want to repeat steps 1 and 2. Which means we want to isolate that radical, this right here, and then raise both sides of the equation to the second power. So let me isolate this radical. I'll subtract 5 from both sides, and I'll subtract x from both sides. So these cancel, and these cancel. And on the left, now I have 3x, subtract x is 2x. 1 subtract 5 is negative 4. Then on the right side I have 2 square roots of x plus 4. Now we could divide both sides by 2, and I think I will. Sometimes this left side won't divide evenly by this coefficient of the radical, but even still, you can work with fractions. On this one, I'm going to go ahead and divide both sides by 2, which means I divide every term by 2. So this cancels. 2 over 2 is 1. And on the right side, I have the square root of x plus 4. On the left, I have 2x divided by 2. That'll just be x. Then 4 divided by 2 is 2. So I have x minus 2. So that takes care of step 1 again, where I'm isolating the radical. And now I still need to raise both sides of the equation to the second power, since my index is 2. When I do that, on the right side I have squaring a square root, so I just have x plus 4. On the left side, when we square a binomial, it's the same as multiplying it by itself. So we can use FOIL on that. X times x is x squared. X times negative 2 is negative 2x. And then negative 2 times x is negative 2x. And negative 2 times negative 2 is positive 4. I want to solve my resulting equation. Because it has x squared in it, we're going to have to solve it using one of our methods for solving a quadratic. I'm going to go ahead and move everything to the left side and set that equal to 0. My equals are reproducing. Okay, so I have x squared already on the left side. Subtract x from both sides. So I have negative 2x and negative 2x. That's negative 4x. And then minus x is a negative 5x. And then I can subtract 4 from both sides. And 4s are going to cancel. And these canceled. So it looks like our equation simplifies to x squared minus 5x equals 0. Now this factors nicely. I can just factor out the common factor here of x. And I get x minus 5. And that equals 0. Now let me caution you. Some students would think that they can move this negative 5x and move it to the right side and then divide both sides by x. But this is not recommended. You should never divide by a variable because the variable could be 0, and that would open you up to division by 0, which is undefined. So if we solve this equation, we have two factors multiplied together equaling 0. So we can set each factor equal to 0. And so there's our x equals 0 is 1. And then this one x minus 5 equals 0. You can add 5 to both sides, and we get x equals 5. Now, before you can go on to the next problem, then you need to check your solution in the original equation. So my original equation is up here. I'm going to copy that down and then we can check it. The original was square root of 3x plus 1 minus square root of x plus 4, and that has to equal 1. Alright, let's check 0 first. So we have square root of 3 times 0 plus 1, subtract square root of 0 plus 4. And that, we don't know if it equals 1 yet, so I'm just going to put a question mark there. This first term is 3 times 0 is 0, plus 1 is 1. So I have square root of 1, subtract, and this one is 0 plus 4 is 4, 2. So I have 1 minus 2, and that is equal to negative 1, which is not 1. Okay. So 0, which is the number I was checking here, does not work. Now let's check x equal 5, and you do need to check both because sometimes neither one of them work. We're putting our 5 into this equation, so we have square root of 3 times 5 plus 1 minus square root of 5 plus 4, and we want to know if that's equal to 1. 3 times 5 is 15, plus 1 is 16. So I have square root of 16, subtract, and then 5 plus 4 is 9, so square root of 9. Square root of 16 is 4, square root of 9 is 3, 4 minus 3 is 1, and so those are equal, and this is the only solution that I can give for this equation. X equals 5.